Let's look at this question. 4m square m log 2 raised power m plus something 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 and another log term something something are positive and are in geometric progression, then the value of m is equal to. In such questions, my go-to move is just fit in the values and see what works. But the problem here is n is not defined. Here, right now, there is also another variable n. So I can't do that. I will have to go down the technical route. So I would get log base n 2m plus 1 minus 7. This whole thing, sorry, not whole thing, raised to the power m. Now this whole thing square should be equal to 4m square into log base n 2 raised to the power n minus 5. This whole thing square. Given that each of these terms are positive, I can cancel out the perfect squares. Okay, so this is gone. This will now turn to 2. This is also gone. Okay. What else can I do? So I can write this as 2m log base n. Okay. So I get log base n 2 raised to the power n plus 1 minus 7 is equal to log base n raised to the power 2m. But I'm multiplying these things. Why do I even need this? This is not even important. I can get 2m to the power log base n 2 raised to the power n minus 5 raised to the power. Oh, there was an m inside. M. And this will be raised to the power 2m now. Fine. So I can remove the log portions now. From the power, I can remove 1m. Okay. So now I have 2 raised to the power m plus 1 minus 7 is equal to 2 raised to the power n minus 5 whole square. And now I have been able to remove the influence of n altogether. Now I can fit options. Let's see. If I put m equal to 1, I will get 4 minus 7 minus 3. This is perfect square. So this is not the answer. If I put m equal to 2, so 2 cube minus 7 gives me 1. 2 square minus 5 will give me 1. So this works. But does this cause any of the expressions to turn to negative? Yes, look at this. If m is equal to 2, log 2 raised to the power m minus 5, this will turn into a negative term. So 2 cannot work. This is impossible. Let's go m equal to 3. At m equal to 3, I will get 2 raised to the power 4, 16 minus 7, 9. And 2 raised to the power 3, 8 minus 5, 3 square, 9. Yes, everything works. This is acceptable as of now. Let me see if it derails anything. No, this remains positive. This also remains positive. So it seems like the right answer, but as of now, not marking. I will also check the last one. 2 raised to the power 5 minus 7 gives me 25. Great. And here I have 2 raised to the power 4. 16 minus 5 is 11 square. No, this is not even matching. So this is not the answer. So the only one left among the options is option C. That will be your final answer.